Hello, Wranglers. All right, so we learned the first part of Pythagorean theorem last time, but now it's time to move on to the second part. All right, second part is a little more difficult, but it's still not that bad. All right, so I know some of y'all might have whizzed through that worksheet last week. I get that. All right, but this time it's going to be a little bit, like I said, a little more difficult. So pay attention and let's see if we can get this. All right, if y'all take a look at the first one that you guys have, all right, you got this nice looking triangle like this, right? And then it says, right there, it says this side is 13, right? And then the other side right here is going to be 11 on the bottom here. Now, so if we're looking at this problem, how are we going to use a Pythagorean theorem to find the missing side? Now, if we look, the missing side is right here. We don't know what the side is, right? So I'm going to put a little question mark right there to say that's what we're missing. We're missing that side. But remember, we talked about the Pythagorean theorem being a formula. And you remember the formula was, once again, a squared plus b squared equals c squared. Okay? So we know that's the formula. And remember, a and b, we don't really care which one is which. It could be A or B, you know, they can move back and forth. C is the important one. We got to make sure that C is a specific number. Now, how do we find C? Remember what we did last time. We took from this vertex right here, right, this vertex right here, what we did is we drew a straight line across. And whatever side we hit, which happens to be this side, this right here is going to equal C every single time. All right, so once again, when you draw a straight line from this vertex up here, boom, that's going to be the C. So my C is going to need to be 13 squared, which leaves, is this going to be A or B? Once again, it doesn't matter. Now, I myself, I like to make the side I'm missing, if I'm missing a side, I'm going to make this A. So this is going to equal A, and this is going to be B. Okay? Like I said, you can flip them around, doesn't matter. So my A, we don't know what it is, so I'm going to leave it A. So this is going to stay A squared. Plus, now what's my B? My B we said is 11, so we're going to put an 11 here. 11 squared, and that's all going to equal 13 squared. Now all we need to do is solve the equation. Now if we look, the A squared, we can't do anything with it, so we're just going to bring this guy down. A squared, just like that. Then plus. Now, what is 11 squared? 11 squared is 11 times 11. 11 times 11, of course, is 121. And that's all going to equal 13 squared, which is 13 times 13, which is 169. Now that we got this, what we're going to do now is we're going to get A all by itself. It's a two-step process. First step, get rid of what's being added to the A. Now, what's being added to the A squared? The 121. So let's get rid of that. And the way we get rid of this is by adding the opposite. What is the opposite of 121? Negative 121, right? So we're going to add that to both sides. Those are going to cancel out because 121 minus 121 is 0. Then we get this A squared right here, and that's all going to equal. And now we're going to do some subtraction here because those signs are different. So we get 169 minus 129, 9 minus 1 is 8, 6 minus 2 is 4, and of course the ones are 0, so we got it right here. A squared equals 48. So was that our answer? A squared equals 48? Nope, because A needs to be by itself. I said it's a two-step operation. The first step was adding the opposite here. The second step is getting rid of the square. Now how do we get rid of the square? Anybody remember? Square root. Right? So what we're going to do is we're going to take this A squared and we're going to square root this side and we're going to square root this side. So we got to square root both sides, and when we do this, what happens is the square and the square root are going to cancel out, right? Leaving us with A is equal to. Now, do we know what the square root of 48 is? Can we think of two numbers that multiply to itself to give us 48? I know some of y'all might be thinking, hey, wait a minute, 24 times 24. That's 24 plus 24. Okay, that would be 48. But there's nothing that's going to multiply together that's going to give us 48 using the same number. Therefore, we're going to leave it just like this. The square root of 48. And that's it. So when we got this right here, That's going to be our answer. A equals the square roots of 48. All right? And that's it. That's part 2. If you can do this, you can do part 2. Now, hopefully that made sense. If not, don't worry. I got another one for you right here. Okay? Now, real quick, this next one here. If we look, this next one looks a little different. Look at this. Looks like this. Goes way up tall like this. The right angle right here. This is 10 and this is 8. Okay? So when we look at this, oh, excuse me, this is a 9, not an 8. A 9. Can't see, I'm getting blind too. All right. So now we got this 10 and this 9. Now what we're going to do next is now we're going to go ahead and we're going to find our hypotenuse. Remember, the hypotenuse is your C, because we're going to find the values for a squared plus b squared equals c squared, so we can plug them in and solve. So to find c, once again, what we're going to do is we're going to go to this vertex and go across the triangle until we hit this side. This side is the hypotenuse. This side is my c. So I know that c is going to equal 10. So in my formula, for my c, I'm going to put a 10 there. So this right here is going to be 10 squared. Now, which one's a, which one's b? I don't know. I'm going to say this one down here is A, and I'm going to say this one right here is B. Okay, so there's my A, there's my B. Now let's go ahead and plug them in and see what we get. All right, so A, we're going to leave A. That's A squared plus B is 9, so it's going to be 9 squared, and that's all going to equal 10 squared. Okay? Now, the next thing we're going to do now is now we're going to go ahead, we're going to solve. Now, we don't know what A is. We can't do anything with the A, so we're just going to bring them down. So here we go. A squared plus 9 squared. 9 squared, 9 times 9 is 81, so I'm going to put an 81 right here. And then finally, we're going to go 10 squared. 10 squared, people, is 10 times 10. That's 100, so we put 100 here. Now, two-step process, remember? First step, get rid of what's being added to a squared. What's being added? 81. What's the opposite of 81? Negative 81. So what I'm going to do here is I'm going to put a minus 81 here and a minus 81 here. Now when I do this, 81 minus 81, 0, those cancel out. Leaving a squared is equal to 100 minus 81. We subtract those. Boy, that's a toughie. It's 19 though, right? So we're going to put a 19 here. Next, how do we get rid of that squared on the A? Square root. So what I'm going to do here is I'm going to take this A squared and I'm going to square root this side and then square root the 19. Now, a squared and a square root, they cancel each other out. So this square root right here, boom, and this square, boom, are going to cancel each other out, leaving just an A. Now, once we get this, once again, we're going to ask ourselves, do we know what the square root of 19 is? Now, I'm thinking two numbers multiply together to give us 19. Not going to happen, folks. Square root of 19 is going to stay the square root of 19. So I'm going to go ahead and write that down. And that's it. A equals the square root of 19. And that's my answer. Okay? That's all we had to do. Now, hopefully this made some sense. Okay? Now, what happens? What happens? Real quick. Let me do one more right fast. Because I don't want anybody to get confused on this now. That's the last thing I want. So let me do one more real quick. Because I thought of one that y'all might have trouble with. Okay, I thought of one. Take a look. Look at this one. Number 3. Oh, my goodness. Look at this one. Right? We got, oh, that's an ugly one. There we go. Look at this. We got 14 here. We got 5 here, right? Now, let's try this one. Once again, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So we got a squared plus b squared equals c squared. Now, what's my c? How do we find it? Remember, start from our box, draw a line from the vertex, and see what line you hit. You hit this side. Now, uh-oh, we hit a blank. Doesn't matter. That's my c. This is what we did last time. Now, so my question is this. Which one's A and which one's B? Don't matter, right? So let's go ahead. Let's say that this right here, let's say this is A and this is B. Because it doesn't matter. My A is 14, so it's going to be 14 squared plus My b is 5. So it's going to be 5 squared equal c squared. Now, 14 times 14. Oh, that's a big one. I don't know that one. So I'm going to go ahead and multiply it out. 14 times 14. So you don't need a calculator. You can just multiply it out like this. 4 times 4 is 16. Carry the 1. Look at that. 4 times 1 is 4 plus 1 is 5. There you go. Get that zero spacer. Boy, this is fun. 1 times 4 is 4. And we got 1 times 1 is 1. Now we're going to add this up. 6, 9, 1. 196. So this is going to be 196 plus 5 to the second power. 5 times 5, we also know is 25. And that's all going to equal c squared. Now here, are we going to add any opposites to the other side? No. Okay, we're not, because the c squared is already by itself on one side of the equation. That's what you want. So what you're going to need to do is you're going to need to add 196 plus 25. Now, when you add 196 plus 25, let's see what we get. I get a carry the 1, I get, look at that, 2, I get 221. Okay, now, when I got 221, I'm going to write this right here. 221 equals c squared. Now, we're still not done. Because remember, you're not looking for c squared, you're looking for c. So we got to get rid of that square. And the way we get rid of the square, square root. The square root will get rid of that square. So here we go, watch. We're going to square root that c squared, and we're going to square root that 221. Now, are there any numbers that multiply together that are the same that will equal 221? Nope, not going to find one because there isn't one. Okay, so our answer is going to be square root of 221 equals, and don't forget, square to square root, cancel, cancel. We get c, and that's our answer. All right, now that was part 2 of the Pythagorean theorem. Told you, not much more difficult, but that one extra step confuses folks. So anyways, I hope y'all understood this concept. All right, have a great day, and we'll see you later.